following example, we're asked to find the distance a car travels while stopping, given its acceleration once the brakes are applied, and its initial velocity. So summarizing the information in the question here, the acceleration is negative 4t. It is traveling at 32 meters per second when the brakes are applied. So the velocity at time 0, because we're going to start when the brakes are applied, is 32 meters per second. How far does it travel while stopping means we're going to have to find the position function, and we need to know how long it took to stop. So we're going to have to find a t value here to plug in to calculate how far it travels. So we're going to need to know how long it takes to stop. We do have one other piece of information. We know that once it stops, the velocity is 0. So the velocity at the end is equal to 0. So we want to know what is the position when the velocity hits 0. Essentially, that's what we're looking for. So we know the acceleration. We can integrate to find velocity. So let's start there. The integral of negative 4t with respect to time is going to tell us the velocity is equal to negative 2t squared plus a constant. Using the fact that the initial velocity is 32, putting 0 in here, equal to 32 tells us that c equals 32. So the velocity of the car is negative 2t squared plus 32. Now, we're going to need the position of the car, so let's isolate our information there, and let's find the position of the car. So the position of the car has to be the integral of velocity, so that's the integral of negative 2t squared plus 32 with respect to time. Integrating then gives us negative 2t to the 3 over 3 plus 32t plus a constant. We don't have any information about where the car started, but since the problem is beginning with the brakes being applied, we can set the initial position. So another piece of information here. The initial position can be 0. So at time 0, position is 0. That tells us that the c here is 0. 0, 0, so c equals 0. So s of t equals negative 2t cubed over 3 plus 32t. Now, this is our equation for the position, but in order to know how far it travels, we need to know the time. So we need to figure out when does this car stop moving. That means the velocity is equal to 0. Using the equation for velocity then, and setting it equal to 0, we can find how long it takes for that to happen. So solving this equation, this becomes negative 32 equals negative 2t squared. Dividing each side by negative 2 leaves t squared equals 16, and that means t equals plus or minus 4. Since we're dealing with time, we'll disregard the negative and we'll just say the time is 4 seconds. If we know it takes 4 seconds to stop, we can put 4 in for t here and find how far it travels in those 4 seconds. So taking this equation now, s of 4 then is equal to negative 2 times 4 cubed over 3 plus 32 times 4. Evaluating that gives us 85.3 repeating meters, or as a fraction, 256 over 3.